project is What Makes a Book a Bestseller? Predicting a Book's Bestseller Rank by Audrey, Zoe, and Faith. And our project was to analyze various features of books within a depository to see if we could use aspects of it to correctly classify where it would fall on a list of bestsellers. And our problem was supervised machine learning because we would break down the bestseller rank into different ranges and predict which of those ranges a given book would fall into using classification algorithms. And we managed to get up to a 46.3% accuracy on our test set. And our problem was significant because if we can determine which features of a book are most important to it gaining bestseller status and seeing if it can be predicted using those features, then it could be useful in the future for classifying unknown books into a bestseller capacity, and we could use this to predict market trends. And there has been prior research into this topic. Like in 2016, a novel called The Bestseller Code: Anatomy of the Blockbuster Novel was published, and they managed to get their machine learning algorithm to predict whether or not a book would become a bestseller with an accuracy of about 80%. And given our problem, we are hoping to tackle the questions of which machine learning algorithm would be the most effective at predicting our target, how important will rating average of a book be, and will some features cause more change to our target than others. And some of the hypotheses we want to test is that we think KNN will not be very effective at predicting our target variable because a lot of our features are not numeric originally, so it would be kind of nonsensical to categorize them as closer or further away. And we think that rating average, publication date, and category will be some of the most predicting features toward our target variables.
So we get our data set off of Kaggle, and it originally had 26 columns and around 56,000 rows. And since this is a classification problem, we use the following algorithms: k-nearest neighbors, Gaussian naive Bayes, multinomial naive Bayes, decision tree classifier, random forest classifier, and ADA boost classifier. And we did a lot of cleaning to our data, removing some columns and transforming the rest into quantitative information. And we also removed rows that had some empty columns. And then we did a lot of visualizations to our data. This is a histogram of our dependent variable, which shows that a lot of our data is skewed right. And we also plotted a lot of our dependent variables against our independent variable, and we couldn't see a whole lot of correlation just based off of these scatter plots alone. So we ran some hypothesis tests in order to see if there was significance, and we ran Spearman P hypothesis tests and found significant results among rating average, dimension Z, rating count, publication date, and author. And after running our machine learning algorithms, we found a little bit of accuracy, but also a lot of overfitting. So we also tried to optimize our models in order to get the best parameters, and we ran them using our best parameters down here.
So after comparing these 6 classification algorithms on the 7 most relevant features and then tuning the 4 best of those models, we found that the random forest classifier was the best model for this. We got a 46.3% accuracy. And even though there was still a bit of overfitting on this model, we would still recommend it for this task. Now, since we had 10 possible bins that our target could be in, this model is more accurate than random guessing, so we could believe that we could theoretically use these features to at least get a sense of where a book will fall on a bestsellers rank. For our hypotheses tests, we found that the author has an effect on the bestsellers rank. Also, the thickness, rating average, and rating count, when those go up, the bestsellers rank goes up, so it gets higher on the bestsellers list. Whereas for the publication date, a later date puts a book lower on the bestsellers list. In future work, we would be interested in getting more data on the books, maybe even analyzing the text inside the book to try to predict bestsellers rank. And we'd be also interested in creating a book recommendation engine powered by these features. Thank you.